you ready to get smart? How a smart home works. Wi-Fi, Zigbee, Z-Wave, Bluetooth. Explained. Learn it now. This is episode number 3.
Welcome to the 1 Hour Smart Home Podcast.
Helping you make your life better.
Using automation and technology. With your host, James Both.
Hello and welcome. This is your host, James Both, with the 1HourSmartHome.com, bringing you everything you need to know to automate your home, your life, as well as smart home product reviews, the latest smart home industry news, and exclusive interviews with smart home industry experts and smart home company founders. Ladies and gentlemen, welcome to episode number 3 of the 1 Hour Smart Home Podcast. Today, we are going to be covering how a smart home works and the different smart home protocols that are used to control smart devices within your home. So we're going to cover Wi-Fi, Zigbee, Z-Wave, and Bluetooth. We're going to talk about the number one protocol, which has been used for a long time, which is Wi-Fi. Wi-Fi, you're familiar with it. It's been around for 20 plus years. You have your phone connected to it, your computer connected to it. You can get streaming music on streaming speakers through it. There are a lot of Internet of Things connected smart home devices that work on Wi-Fi. Wi-Fi is a great platform for Internet of Things connected devices that have a power source. So Wi-Fi is very reliable if you have a home network. It is easy to program connections in between devices with Wi-Fi, and it's got a track record that works. So if you have an Internet of Things smart home product that you're going to place in your home and you know you've got Wi-Fi coverage throughout your house, it's going to work. There's no questions about if there's a connection, not a connection, as long as you have a strong network. Now, the disadvantage of Wi-Fi is that it uses a lot of power. So Wi-Fi is not great for battery-powered devices such as smart locks, sensors that need to remain on for years at a time, or tracking data. Really, Wi-Fi is good for devices that are going to be plugged in or hardwired in for a long period of time so that they have the power they need to communicate with your home Wi-Fi network. A lot of the devices that work with Alexa and Google Home are Wi-Fi devices, and the devices that we sell are Wi-Fi devices, and they work great with Wi-Fi networks. Now, another part of this is 2.4 gigahertz versus 5 gigahertz Wi-Fi networks. 2.4 gigahertz is the standard that is utilized for smart home devices for Wi-Fi networks. A lot of Wi-Fi routers these days have both a 5 gigahertz network and a 2.4 gigahertz network. It actually doesn't mean that the 5 gigahertz network is twice as strong or twice as good as a 2.4 gigahertz network. It's actually the exact opposite. The reason that Wi-Fi router manufacturers made these two different bandwidths is because there's a lot of stuff crowded onto 2.4 gigahertz, and on the bandwidth of 5 gigahertz, there's less crowding. However, 2.4 gigahertz comes in just as strong as a 5 gigahertz network, if not stronger. The reason that the networks were made different bandwidths was to split up traffic on networks so that Wi-Fi systems could be more reliable and have less interference. Now, with that being said, the Wi-Fi routers of today are very good. They have different channels. They work really well. So you don't have the interference issues that you might have had 5 years ago with Wi-Fi. We've got recommendations on our website for what is the best Wi-Fi router for your home. I personally use an Eero system. It's great because it repeats throughout the home and it's very easy to expand. We've used these when we're building homes, designing homes, or installing smart home products in huge houses that are castles, that have tunnels and garages that are, 100 feet away or 200 feet away. Eero has worked great for that. So if you're looking to upgrade your Wi-Fi system, that's an excellent option. But getting back to Wi-Fi, 2.4 gigahertz, 5 gigahertz, it doesn't make a huge difference in terms of capacity and stuff going through the network. But what is important to remember is that the majority of smart home devices connect to 2.4 gigahertz, which is the standard Wi-Fi bandwidth. So if you're having problems with a Wi-Fi device connecting to your network, make sure that you're connecting to the 2.4 gigahertz network. And all Wi-Fi routers that have been made in the last 10 years have a 2.4 gigahertz network. So it's not something that you need to look for on the side of the package or make sure that it has it. They all have it if they were made in the last 10 years. And if you haven't upgraded your Wi-Fi router in 10 years, I'm worried for you. I wonder if this podcast is even streaming to you right now inside your house. So, Wi-Fi is great in terms of compatibility, its ease of setup, and for you to know that a product is going to work consistently on your smart home network. So for light switches, Wi-Fi devices are great. For plug-in outlets, Wi-Fi connection to your smart home is great. For hardwired outlets, also really good. Hardwired fans, smart Wi-Fi fans, that's great as well. So anything that is hardwired that has a consistent power source, Wi-Fi is the way to go. A couple years ago, I used to recommend Z-Wave devices over Wi-Fi. And the reason is that the app development and the development side of Wi-Fi wasn't as good back then as it is now. But Wi-Fi, in terms of the standards for smart home protocol and the security aspects that are being built into applications, have far surpassed what Z-Wave was in terms of functionality and usability for the smart home. So Wi-Fi is the number one thing I would recommend if you have a device that can utilize it, that has constant power. That is the way to go. But if you have a battery-powered device, Wi-Fi is not what you want to use. So let's move on to Z-Wave. Z-Wave is a mesh networking protocol that uses very low energy, is very consistent, has a standard across all Z-Wave devices, and each Z-Wave device can repeat the signal of another Z-Wave device. So if you have a Z-Wave light switch and a Z-Wave plug, those are going to be interoperable. Z-Wave is great as a mesh network because each node in the home or each device can repeat the signals of other Z-Wave devices. So the more devices you add to your home, the stronger the Z-Wave signal is throughout your home. It's a mesh network repeating the Z-Wave signal. And for a smart home device like a light switch, it uses very low amounts of data. It's really just an on-off signal and a status signal. So Z-Wave is great for routing little bits of data throughout your home and creating a very strong, reliable mesh network for your home. Z-Wave common devices are light switches, plug-in outlets. There are smart Z-Wave locks, which work really well, motion detectors and sound detectors, glass break sensors. There are a lot of opportunities for Z-Wave devices to be implemented in the home. The other great thing about Z-Wave that Wi-Fi doesn't have is that Z-Wave, because it uses such a small amount of data, it is very low energy. So you can put Z-Wave battery-powered devices on a network and they will last very long. For example, I've had a Z-Wave motion detector. The batteries on that last 2 to 3 years. For Z-Wave locks, the batteries on last anywhere from a year to 2 years based on how cold it is, how much use you have on the lock, and they consistently work, and every Z-Wave device makes the network stronger. Now, the shortcoming with a Z-Wave device or Z-Wave network is that Z-Wave requires a hub. So the common hubs out there are HomeSeer, Wink, SmartThings, Control4, I believe, has some. There's a variety of different smart hubs out there on the market. My favorite Z-Wave hub is SmartThings. But what that means is that you need to have a device that converts internet signals into this Z-Wave mesh network signal, and then that network signal is repeated throughout your home. I really like Z-Wave, and it is very reliable. The issue is that not all smart home hubs are as reliable as Z-Wave is. So if the internet service or the cloud service of that smart home hub goes out, your Z-Wave network won't work. That's what's really important to understand. There are some hubs that have battery backup, that have internal programming for your Z-Wave network, so you'll have limited functionality, limited command and controllability. But the reality is, if it's not up and running at the web service level, it's just not as good as what you wanted and what you intended it for. So that is the downfall of Z-Wave or Zigbee or any of the other protocols that we talk about that aren't Wi-Fi, is that they, for the most part, require a hub to communicate that to the devices, because Wi-Fi routers, for the most part, don't have Z-Wave functionality built into them. Zigbee. Zigbee is very similar to Z-Wave. It's a great protocol. It's used in a lot of devices. Zigbee, though, is not used just for home automation, though. Z-Wave is a more standard home automation protocol, primarily used only for home automation. There's a couple other applications, but it's primarily in the home space. Zigbee is a chip that is manufactured based on a standard, and there are multiple manufacturers of Zigbee chips. And each one of those chips can have a slight different variation in it. Zigbee is supposed to work like a mesh network like Z-Wave does. But the difference is Z-Wave has total control of the chip manufacturing. There is only one manufacturer who manufactures Z-Wave chips, which makes it very easy to make sure all Z-Wave devices connect and communicate together properly with each other. As you can imagine, since the Zigbee chips are manufactured based on a standard with a lot of different manufacturers, there are slight variations in the chips and chip architecture, which makes Zigbee devices not always compatible with each other. On top of that, with Zigbee, you have manufacturers adding their own firmware into the Zigbee chips and the Zigbee protocols that make it so certain devices on a Zigbee network can't contact other Zigbee network devices without a hub, or if they're different manufacturers, they won't work. So Zigbee is great. There's a ton of applications for it. And Zigbee is also used outside of home automation. There's healthcare applications for it. There's a lot of wireless monitoring applications and industrial applications for Zigbee. But all those applications have different chips, different architectures, and they're all meant to do something different. So the standardization for Zigbee is not there. The two most common devices you probably know that have Zigbee in them are the Philips Hue device. So the Philips Hue bridge has a Zigbee hub in it, and that turns a signal from the internet and cloud on Philips's server into a Zigbee signal, and the Zigbee signal will then transmit to the Philips Hue light bulbs. Those Philips Hue light bulbs are then controlled with the Zigbee signal to turn on or turn off. Zigbee is also available on the new Amazon Echo Plus. And what that does is provide a hub-like functionality for the Amazon Echo Plus where it can communicate directly with Philips Hue light bulbs. Now, like we said, there are a lot of different standards on the Zigbee platform. So in order for future devices to connect to Amazon Alexa's Plus Hub, the manufacturer manufacturing the device, whether it be a smart light switch, a smart light bulb, or a smart plug, they need to put in the work, the effort, and the programming to make sure that it would be compatible with the Amazon Alexa Plus smart home hub. That doesn't always happen. So the other home automation hubs that we mentioned before, SmartThings and Wink, those hubs have a Z-Wave chip. They also have a Zigbee chip in them. In terms of distance, both Z-Wave and Zigbee are fairly comparable in terms of how far the signals will travel. Zigbee might have a little bit of an edge, but both of them, I would say, about 100 feet unobstructed work pretty well. Now, if you've got concrete walls or brick walls, Zigbee and Z-Wave is going to decline very rapidly, so you need to create extenders for your network, whether that's a Z-Wave repeater by adding another device, such as a light switch or plug-in device, or a specific repeater, and Zigbee is the same way. So all of these items typically in a Z-Wave network will work as a mesh. Zigbee, it will sometimes work as a mesh. It depends on if you have the same manufacturers, which means that a Philips Hue bulb can communicate to another Philips Hue bulb with the Zigbee protocol. However, you can't have another Zigbee manufacturer right now communicate with the Philips Hue bulbs and then back to the hub. So you are limited by distance with the hub to the device you are trying to control. It's just something to keep in mind there, that not all Zigbee devices repeat like Z-Wave devices do. So that's an important caveat for you to understand. Now, there's another protocol. It's the biggest, smart home device player out there, Nest. And that's called Nest Weave, Nest Thread. And that is how Nest advertise it as their own proprietary system. But really, Nest Thread and Nest Weave are a Zigbee protocol or a Zigbee chipset. The difference is that Nest has created their own proprietary way of creating the Zigbee network so that all their devices connect and communicate with each other very well. The downside of this is that those devices right now aren't opened up to communicate with other non-Nest devices, and there are a lot of developers who don't necessarily want to commit to a standard that is owned and operated by Google, because if they want to make changes or it doesn't work for their specific device, they have to deal with Google to do that, and Google would be under no obligation to make those changes. However, it does work very well for devices within the Nest system. So devices that use Thread and Weave right now are the Nest smoke detectors, the Nest locks. If you see the Nest Connect that is used for a lock, that little device basically turns Wi-Fi into the Zigbee Weave Thread protocol for Nest, and then communicates with the lock. Because Zigbee is so much lower energy than Wi-Fi, it allows those lock batteries to last a very long time. So Zigbee and Z-Wave, in terms of a smart lock, the batteries last about the same because they're both low energy standards for communication. The Nest security system also works on the Thread protocol. So the actual hub for the Nest security system is outputting this Thread, Weave, Zigbee protocol to the other sensors within the network. And those sensors are window or door sensors and you just paste them on a wall and then they work. So the range for that we've seen is about 100 to 150 feet for the thread weave protocol. It could go longer than that, maybe if you're in an open field, but if you were to need to repeat this thread weave nest protocol, you either need to have a device inside your house that is repeating it already, or you get a Nest Connect, which basically converts Wi-Fi into this thread protocol as well as repeats thread commands throughout the network. Now, the last protocol that we're going to talk about is Bluetooth Low Energy or Bluetooth Mesh Networking. So Bluetooth has been around a long time, just like Wi-Fi has. Bluetooth is really good for low energy devices. You probably have used or have a Bluetooth speaker or jam box or Bluetooth in your car, so you are very familiar with how it works. You turn the Bluetooth radio on your phone and you can control devices. There are some devices right now that are using Bluetooth, such as smart locks. Another one that is using Bluetooth is the Flick smart button, and that connects directly to your phone, and then your phone interfaces with the internet and web servers to be able to control other devices that are connected through the web or through the internet. Bluetooth is good, but once again, there are a fair amount of different device standards, so there's not a lot of devices that have mesh networking capabilities built in. However, Bluetooth is a low energy protocol, so you can have devices like Flick buttons controlling other devices, and that device will last a year or 2 years because the battery usage is so low. Bluetooth is great for sensors and things that you want to run on batteries, but the overall market hasn't created a standardized mesh Bluetooth networking protocol that is widely adopted by a lot of other people. So typically what you see with a Bluetooth device is that Bluetooth device will communicate directly with your home, or in some cases it will communicate with a home hub. Bluetooth is also used in popular devices like Amazon Alexa. You can communicate directly to the hub via Bluetooth, so you could stream music from your phone if you didn't want to go through the web services, if you had music stored directly on your phone. And you can also use it on the majority of Amazon Alexa devices, where you can stream directly from your phone to the Amazon device without the need to be connected to an internet network. You're just making a direct connection between one device to the Amazon Echo, and you are streaming music through there. So Bluetooth can do that. In terms of using it for home automation in light switches, I haven't seen that yet. Where it's primarily been used is in smart speakers, buttons or sensors that need battery power for a long period of time, and smart locks that interface with your phone, and you walk up and it's getting the Bluetooth signal and you connect to it and you can open your door with Bluetooth. In terms of what I would recommend for devices going forward and what protocols you should pick your devices around, I would say focus on Wi-Fi devices, because they will have the most interoperability with platforms, and the ease of connection to an app and to the web service does not have a hub in between the Wi-Fi device and the cloud that you're trying to communicate to. Whereas if you have a Zigbee, Z-Wave, or Bluetooth, not always with Bluetooth, you have those protocols, they need a hub that translates from Z-Wave or Zigbee into the cloud protocols and into the internet, which introduces another point of failure. So if you have something that is going to use power, go with Wi-Fi. If you have something that is going to use a battery option, you can go with one of those other protocols such as Z-Wave or Zigbee. My personal preference is Z-Wave because of the reliability of the Z-Wave mesh network and the standardization of the chipset design and the fact that the majority of Z-Wave devices will work together and repeat the signal flawlessly, which you don't always have with Zigbee. Now, that's not to say that Zigbee doesn't work and doesn't have its place, because it does, but primarily with Zigbee, you're looking at a device that is going to connect to a hub, then go to the cloud and web service, and then it's going to do its thing. Now, with all of these different protocols, we haven't really covered it yet, but we'll kind of just draw you a picture in words on how devices work and interface with the internet. So for the example here we're going to use is, let's say you have a Wi-Fi smart plug. For a Wi-Fi smart plug, you're going to plug it in to a device, a power device, a power outlet, and then you are going to put it in pairing mode. Usually you press the button on the side of the device for 5 or 10 seconds. It puts it into pairing mode. Every manufacturer is different. That device is then sending out a Wi-Fi signal that your phone will pick up on the app. Your phone connects to the device with the Wi-Fi signal, and your phone is also connected to the Wi-Fi network in your home. It recognizes the device is trying to connect, and it recognizes your home network. And your phone, the app, basically acts as a bridge to give the Wi-Fi information to that smart outlet or smart plug, so that then that smart plug internally is able to save your home Wi-Fi network. Once that smart plug has the Wi-Fi network saved in it internally in that information, it will then be able to communicate directly to your Wi-Fi router without the need of you being to be in the middle with a phone. So that smart plug now has a connection to your Wi-Fi router, and that Wi-Fi router has a connection to the cloud where all the smart device commands are stored and executed. So let's say you have a Wi-Fi plug smart switch that you want to turn on and off installed now. It is connected to your network. You would go in your app and you press on or you press off. That command goes to a cloud server in the internet, and then that cloud server relays that information back down to your router in your home, and then that router takes that command, converts it into Wi-Fi, and it sends it to your smart switch to turn it on or off. And likewise, that device will be sending information about its status. When you have a functionality such as a timer or additional functions, those functions are really just cloud service protocols which are running up in the cloud that will then send a signal after 1 minute, if you set a timer for 1 minute, to turn on or off a device. So the smarts aren't necessarily in the device itself. The smarts and all the different functionality and changes you can make are actually in the cloud itself, which is what's nice about Wi-Fi. Developers can make a lot of changes in the cloud to add additional functionality to devices based on your routines, what you're doing, and how the use cases for a particular device are. And then they're able to implement that smart piece of things and just turn on and off the device without having to make a lot of device level changes. So that's pretty much how any of these different protocols work, where a device will send a signal to the cloud, and the cloud will then send that signal back to your smart home device. So cell phone command, cloud, and then from the cloud to your router, and from your router to the device that you have installed in your home. Now, if you have a Wi-Fi smart plug that is installed or works with Amazon Alexa, what happens there? Well, then you say to Amazon Alexa, Alexa, I would like to turn on or off whatever light switch you want to turn on or off. Alexa takes that cloud command after you've connected your device as a skill in the Amazon Alexa app, and that cloud command then communicates with the specific manufacturer's cloud, and it says, I'm Alexa. I would like to turn off your light switch. That manufacturer's cloud then says, yes, okay, you have access to us. We will let you control our device. The Alexa command is converted from Alexa voice into the manufacturer's language of on and off. The manufacturer of the device that you have installed then sends that cloud command to your router and then to the device in your home. And all of these devices, regardless if they work on different protocols, the only difference in the step there is that you might have a hub in between, such as SmartThings or Wink. So I think that's a good tutorial, a good basis on the different smart home technologies. And what you need to take away from this is I would be Wi-Fi centric first for the devices that will work with Wi-Fi. That's where I would start because of the reliability and the adaptability and future-proofing of the Wi-Fi devices. And I didn't always agree with that, like I've said before, but the other part of this equation is pretty much everyone now has a strong Wi-Fi network in their home. And if you don't, you can upgrade that Wi-Fi network using a device like Eero, a mesh Wi-Fi network that is going to allow you to have really strong Wi-Fi signal throughout your home. So I'm not as concerned anymore about not having Wi-Fi reaching parts of your home, which actually used to be an issue a couple years ago on top of some of the other Wi-Fi issues. So if you have a strong Wi-Fi network that's blasting out into your neighbor's yard and across the street, you really don't need to worry about connectivity of Wi-Fi devices anymore. So Wi-Fi first, then Zigbee or Z-Wave second, depending on what use case you have. And then Bluetooth for one-off devices that are connecting to your phone. There are a few devices that connect to hubs on Bluetooth, but very few and far between. Also, Bluetooth is a nice communication protocol between phones and smart speakers. Ladies and gentlemen, thank you for listening to episode number 3, and we are happy to bring you value each time that you tune in. If you've got questions you want us to cover on smart home automation, go ahead and email us at info@onehoursmarthome.com. We always look forward to hearing from our listeners and providing topics that you want to hear about. Now, if you could do me one more favor, go ahead and give us that 5-star rating in the App Store or give us a thumbs up and like and share the 1 Hour Smart Home podcast with your friends.
Thank you for listening to the 1 Hour Smart Home Podcast. We love our listeners and your feedback. Subscribe to our email list at onehoursmarthome.com, where we share with you the best smart home technology, the latest reviews, tips, and tricks to make your life better. And with that, we'll catch you in the future.
This episode was brought to you by the onehoursmarthome.com. And if you want to support us, you can either buy our products, our smart home devices that we manufacture and design on our website, or you can go to Amazon and search 1 Hour Smart Home for products that we sell there.